Hello and welcome to Robotic Surgery Insights. Today we're going to be talking all things encoders for surgical and medical robots. Thanks for joining me today, Paul.
Hi, Joseph. Hi. Nice to be here.
Could you please start by providing an overview to yourself and FLUX?
I'm Paul Tutzu, and I'm the Managing Director at FLUX GmbH, where we specialize in developing and manufacturing high precision position encoders. Our encoders are used in a wide range of applications, including industrial automation, medical, and surgical robotics. At FLUX GmbH, we are committed to pushing the boundaries of what's possible and improving state-of-the-art technology. With decades of experience developing encoders based on various measurement principles, our focus remains on enhancing precision, safety, and reliability.
And which part of the surgical robotic systems typically require encoders?
Surgical robots feature rotary axes implemented through rotary joints composed typically of motor, gearbox, and encoder. The encoder provides critical feedback information about the position, which can be then processed further into speed or acceleration data. While the motor and gearbox are essential for the movement and torque of the joint, it's the encoder that ultimately defines the robot performance. The encoder is a make or break component that determines how precisely and repeatable the position of the joint is controlled and maintained. This performance is critical in surgeries where robotic arms need to replicate surgeons' movement to perform complex tasks like delicate tissue manipulation.
What are the important attributes if you're an engineer selecting an encoder for your surgical robot joint that you should look out for?
When selecting an encoder for a surgical robot, four main attributes must be considered. This is the size, the immunity to the electromagnetic fields, positioning, performance, and safety. Each of these plays a crucial role in ensuring effectiveness and reliability. I will start with the size. Given the space limitation, the compactness of the encoders is critical. The joints are designed to have the smallest axial and radial footprint possible, which requires the encoder to be small and easily integrated. The second, the immunity. Encoders must be immune to the electromagnetic fields generated by the nearby motor. Without this immunity, additional shielding becomes necessary, increasing the overall size of the encoder and hindering the compact design of the joint. Ensuring immunity allows the encoder to function accurately and reliably without adding any extra bulk. Then, the next one is the positioning characteristics, which are another vital aspect of the encoder. High resolution, accuracy, and especially repeatability are key features that define the quality of the feedback. Maintaining precision in these areas guarantees that the robot movements are controlled and consistent, which is mandatory in delicate surgical tasks. And finally, given the risk associated with medical applications and patient well-being, the encoder must be highly safe. Any malfunction during procedures could have significant consequences. Therefore, robust features and high reliability must be guaranteed to ensure patient safety at all times.
Could you talk a bit more about the safety sort of redundancy element of encoder selection?
Yes, sure. So related to the encoders, there are three ways to facilitate certification of an entire surgical robot within the safety framework. The first approach is to use an encoder that is already safety certified. While this option offers some clear benefits, it can be limiting if the application requires additional safety standards or customization that the encoder cannot accommodate without undergoing a time-consuming new certification process. The second approach involves integrating two encoders in a redundant configuration. This method provides a high level of safety while maintaining flexibility in selecting encoder type and interface, plus allows customization. However, the downside of implementing two encoders is that it requires a larger footprint to accommodate them. And finally, we have the third approach, which is to implement a fully redundant encoder. And this encoder incorporates two independent channels within a single encoder unit. These setups deliver maximum flexibility without compromising safety or requiring additional space, as it combines the advantages of redundancy and customization within a compact form factor.
And could you please provide an overview to FLUX's solutions for the surgical robotic industry?
Sure. At FLUX, we emphasize flexibility and customization to ensure that our solution meets the unique demand of surgical robotics. We have developed an inductive sensor that provides a high degree of integration, keeping the encoder compact to fit easily within the constrained spaces of a surgical robot's architecture. Our encoder uses an inductive measuring principle, which makes it immune to electrical and magnetic fields. This immunity allows it to be integrated directly nearby the motor without compromising performance, eliminating the need for additional shielding or protection. This ensures precise, reliable positional feedback even in the high-density electromagnetic environments generated by high torque. The next encoder provides exceptional performances in terms of resolution, accuracy, and bidirectional repeatability. These characteristics are vital in surgical application, where precise positioning and consistent movement are crucial to ensuring optimal patient outcome and maintaining the highest level of surgical precision. And last, when it comes to safety, we offer a fully redundant encoder with the same small footprint as a standard model. This encoder features two independent channels, both with absolute scanning capability, providing fail-safe reliability in critical surgical applications. The redundancy built into the system ensures uninterrupted operation and peace of mind, reinforcing FLUX's commitment to enhancing precision, safety, and reliability in the surgical robotics application.
And you spoke about customization. What does a typical development project look like with FLUX?
At FLUX and for FLUX products, the first step in typical development project is understanding the final surgical robot's requirements and application goals. Next, in collaboration with our customer, we determine whether a standard encoder can meet the application's needs or if customization is required. Customization can encompass all aspects of the encoder, including geometric dimension, electrical specification, interfaces, and many more. For customized projects, we draft a detailed specification that is reviewed and approved by our customer. We prioritize short delivery time for our standard products, ensuring that they are readily available to support immediate technological tries. For customized solutions, our standard products can provide a foundation for initial technology support and prototyping, and allowing quick iterative development. With our development team's highly interdisciplinary expertise in all the domains from above, mechanics, electric, and interface, we excel in delivering complex customization within the shortest possible time. After delivering the first products or prototypes, we continue to work closely with our customers to monitor the system's performance in the development phase of the robot. By gathering insights from practical usage, we can refine and fine-tune the encoder configuration to improve performance, ensuring that the final solution exceeds expectation in precision, safety, and reliability.
So, well, thank you very much for your time and insights, Paul.
Yeah, thank you. Thank you also very much for the interview and for the chance, my chance to present our product and also to talk about integration of encoders in surgical robots.